Bismillah ar-Rahman ar-Rahim. So this is the experiment of projectile motion. So this is the hardware that we are going to use in this experiment. Basically, we have at the bottom a scale to measure the angle. Here we have the timer. And here we have our gun that will shoot the ball. And here we have the release trigger. We have the release trigger. We use in this experiment a special ball. As you can see, it's made out of wood, and it has another piece here at the top. It's made out of metal. Made out of metal. As it's not so clear, but I can just assign. So basically, we put this ball here at the gun, and then we press the gun. We press the gun, we pull it in this direction. It has a spring inside, so we charge the spring. We put the ball here. We reset the timer. This is the reset button. We put the ball, reset the timer. We charge our gun, or we compress the spring for our gun, and then we release it using this ring. As you can see, now I'm pulling the ring, so the spring is released, and the ball will go into trajectory motion. It will go into trajectory motion, in a projectile motion. As the ball passes through the timer records the measurement of the speed of the ball. The speed of the ball. And what is the error of that speed? Well, V is equal to 2.53 plus minus 0.1 meter per second. As I told you before, for a digital device, if it's not mentioned, we assume the accuracy is plus minus 1 on last digit. So here the last digit is 3. So we assume that there is plus minus 1 on the 3. However, some devices, some digital devices have a manual and will give you an equation to calculate the error. However, for simplicity, it's just plus minus 1 on last digit. Now, the ball went into projectile motion. Now I need to measure the distance. So I put the ruler here at the 0 point where I put my ball at the beginning. And then I go for the other side and look for where the ball hit the ground. We put a carbon paper. And then we just record the distance between this carbon paper and the beginning of the ball. Now, why I put this photo Well, the accuracy of the ruler is always fixed. It's 1 millimeter. However, you can see that the size of the ball when it hit the carbon paper, the size itself is about 1, 2, 3, 4 millimeter. 4 millimeter. Then when we measure the distance, the accuracy of the measurement is not 1 millimeter. If you put 1 millimeter, that's wrong. Why? Because there is a difference between the accuracy of the measurement and the accuracy of the tool. Here, the accuracy of the tool is 1 millimeter. The accuracy of the measurement could be 4 millimeter, 5 millimeter. Everything is correct. However, if you put 1 millimeter, it's wrong. So here, this is our projectile. This is, now it is parallel or horizontal. So this is my 0 degree measurement. If I bring this side, all the way to this end, then I'll be measuring a 90 degree. I'll be measuring a 90 degree. Okay, we are going to do measurement. So what's the accuracy of the angle measurement? Well, you can see here, I can enlarge it a little. Here 45, and here is 40, and it's divided into 5 parts. So if I'm using this scale, the error will be 1 degree. The error will be 1 degree. Unfortunately, I am going to use this scale. This scale. So what's the accuracy of this scale? Well, we said this is 0, this is 90 degrees. So let's follow our rule. Error is the smallest division of the scale. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 90 divided by 18, and it will give us 5 degrees. So the accuracy when you use this scale is 5 degrees. It's 5 degrees. So now we are doing 3 measurements, or there are 3 sources of error in this experiment. Measuring the angle, and the accuracy is 5 degrees. Measuring the distance, the range, we call it the range in this experiment, and the accuracy could be 5 centimeter, 4.05 centimeter, 0.04 centimeter, etc. And we have the measurement of the speed. Well, it is 0.01 meter per second. Thank you for listening.